My name is Anushka Chintada, and my topic is combining treatments to fight glioblastoma. I am a member of the Chabra Water CV Chum. In chemistry, in one of the labs we did, we explored precipitates formed by two different solutions. Here is a video showing this. These two reactants often formed different colors and had very different properties when they were combined. I started to research real applications of this and how mixing two different chemicals could somehow be beneficial. While researching, I came upon glioblastoma. Researchers trying to find ways to mitigate or cure glioblastoma often will use two treatments together to make stronger and more effective treatments. Glioblastoma is the most aggressive cancer found in the central nervous system and is the most common brain cancer found in adults. Tumors, called gliomas, are often found in the brain. Life expectancy of patients with glioblastoma is short, and current treatments do not cure patients of the cancer, but rather elongate life. Glioblastoma is a cruel and unrelenting cancer. Recurrent tumors do not respond to treatment, and the survival rate is extremely low. The lives of patients diagnosed with glioblastoma can only be extended on average to 14 months. The fast-growing tumor is relentless. It is not only hard to treat, but a patient usually relapses within 6.9 months of being treated. A patient's chance of surviving for over 5 years is less than 10%. The standard method of treatment is surgery, temozolomide, and radiation treatment. Temozolomide is a chemotherapy specifically for brain cancer, also referred to as TMZ. Many researchers studying glioblastoma today build off the standard treatment used. But how did this treatment come to be? In the late 1800s, William Röntgen gave a revolutionary lecture about a new ray he called X-rays. In the early 1900s, it was discovered that these rays could help cure cancer. Regan was a researcher who experimented with radiation's effects on glioblastoma and discovered that those that received radiation therapy survived on average 5 months longer than those that received another type of therapy called CCNU. Temozolomide was first discovered in the 1980s. For about a decade, Malcolm Stevens and his colleagues at Aston University in Birmingham, UK, experimented with different molecules and eventually found that temozolomide was potentially effective. Their first test with humans was inconclusive, but after changing the doses they gave the patients, they found that the patients greatly improved. Stupp and his team worked with combining these two treatments around 2005. Their groundbreaking work is now the standard treatment for glioblastoma. Temozolomide is made of 6 carbons, 6 hydrogens, 6 nitrogens, and 2 oxygens. It forms an imidazotretazine ring system. TMZ induces apoptosis, also known as cell death, by deactivating DNA using its methyl group and attaching to O6 found in guanine. One research team at the University of Alabama at Birmingham, headed by Boyd and Walker, experimented with carbonic anhydrase 9, or a CA9 inhibitor, referred to as SLC0111, combined with TMZ. CA9 is needed for maintaining the pH, or the amount of hydrogen ions, of a tumor, and SLC0111 works to block the CA9 from aiding the tumor. The researchers used the combinatorial treatment on mice. They found that SLC0111 had little effect on the mice's life when compared to the control group that received no treatment. The TMZ had some effect on the mice's life, but when combined together, they greatly extended the life of the mice, and 2 even recovered. Another study conducted by Angara and team at Augusta University worked with anti-angiogenic therapeutics, also called AAT, and HET0016. AAT blocks the tumor's signals to the bone marrow, which thereby blocks one of the tumor's most important sources of nutrients and restricts growth of the tumor. This diagram shows the process of angiogenesis, the primary way tumors grow. The researchers believed that to make up for this lack of nutrients, the tumor used a secondary growing method called vascular mimicry. Vascular mimicry is when the tumor builds its own channels within itself to transport fluid and to grow. The researchers used the HET0016 as a growth inhibitor and saw that using this combined treatment reduced vascular mimicry in the sides and the core of the tumor. Finally, a research team at Nanjing University in China used FTY20 to increase the tumor's sensitivity to TMZ. FTY20 regulates nuclear factor erythroid-2-related factor 2, also called NRF2. NRF2 aids the tumor by increasing the tumor's resistance to anti-cancer treatments and thereby elongates the life of the cells. When the researchers activated FTY20, the tumor's ability to resist anti-cancer treatments decreased. When the researchers activated NRF2, the tumor's resistance to anti-cancer treatments once again increased. When paired with TMZ, the FTY20 inhibited the spread of glioblastoma cells. I contacted Dr. Anita B. Helge-Malind, one of the researchers who experimented with SLC-0111 at the University of Alabama at Birmingham. She told me that she and her team were planning on designing a clinical trial to determine if the combination is effective on patients. Moreover, researchers also want to continue their research by experimenting on different types of glioma and how to solve the problem of recurrent tumors that do not respond to treatment. Combinatorial treatments for glioblastoma seems like a promising path. Treatments that work together to battle glioblastoma seems to be more effective and lasting when compared to treatments currently used. It seems that, just like the combining of chemicals in the lab I performed, combining treatments when battling cancer can produce effects neither of them had individually. Researchers are working around the clock to battle glioblastoma, and hopefully one day soon, more people will be able to walk out of the hospital knowing they have won the fight against glioblastoma. These are my references. These are my visual references. Thank you for watching.